There's trouble at Mill. Fire has broken out dangerously close to the Rough Science base. Can the team use science to extinguish the flames before it's too late? Our 4 pioneering scientists are Ellen Macaulay, an intrepid go-anywhere botanist with a love of all things wild. Mike Bullivant, a chemistry wizard with a wicked sense of humour. Jonathan Hare, the do-it-all inventor, physicist and engineer. And Hermione Coburn, an earth scientist and explorer who never gives up. Their base is an abandoned mining mill way up in the mountains of Colorado. This is High Altitude Rough Science. Last week, the team equipped the mill with gas and electricity. But with a ramshackle old wooden building as a base, fire is a very real danger. In 2002, much of this region was ravaged by a huge forest fire. But that's not the only hazard in these parts. 100 years of mining have taken their environmental toll and polluted some of the rivers to such an extent that they can no longer support any forms of aquatic life. So this week, our scientists face a battle on 2 fronts, one against fire and the other against pollution. Right, so this week, you're going to be tackling 2 environmental hazards. Now, as you know, this is an area that is very prone to wildfires, either from lightning or people being stupid. So, what we need you to do is come up with a way of extinguishing fires. Any brainwaves?
Fire extinguisher.
Wow, you're good! So early in the morning. Are you going to knock us off a fire extinguisher then?
Mike will do it.
That's not so crazy.
We'll do it.
Do you think you could do it? Yeah. OK, fine. All right. I know a nice red one with a squirty thing. That'd be very good. And the other thing, and this is going to have to be down to you 2 now, okay. Is the water problem. Now, you may have noticed that the river down here looks beautiful, clean, pristine. It isn't. What would be great is if you could come up with some sort of system to stop those rivers being polluted so that they can support life again.
Sounds like we've got to build a water treatment plant.
Of course you have. Just like that.
OK, and then I'll help you.
Yeah, I can do that. I love it. So we're going to have a water treatment plant and a fire extinguisher in 3 days from anything that you can find in the mill and any natural resources you want to plunder. Good. Off you go then. Now, Mikey B, this fire extinguisher, you're not just going to give me a bucket of water and say, done it, are you?
Nope.
OK, what are you going to do?
We're going to produce carbon dioxide.
Right. And why is that going to work?
Well, it's the principle behind a lot of fire extinguishers.
Yeah.
Carbon dioxide is a non-toxic gas. It doesn't support combustion.
Which is a good
flames
thing.
out.
Yeah.
And it's heavier than air.
Right.
So it settles on fires.
So it effectively smothers the fire, does it?
Yes, yeah, it takes away the oxygen in the air for combustion.
OK. So how are you going to make carbon dioxide?
There's a simple way.
Right.
Have a look at this. Sodium bicarbonate in there, and if I add an acid to that, it'll generate carbon dioxide. Now, the sodium bicarbonate, it's a natural resource around here.
OK.
But it's thousands of feet underground, so I'm just using baking soda.
Very sensible idea. Otherwise, I'd have a horrible feeling you get me to do the digging.
Yeah. And I'm going to use vinegar, which is a mild acid.
OK.
Now, watch what happens when I add the vinegar to the sodium bicarbonate. It fizzes up, it produces carbon dioxide.
Yeah.
Put a bit around the side, too. Now, as it generates carbon dioxide, carbon dioxide is heavier than it. It puts the shorter candle out before it will put out the longer candle.
Oh, that's gone too?
Yeah.
So basically, you've got your baking soda, you've got your vinegar, it's made carbon dioxide, it's absolutely proved it, you've got your components.
Yeah.
That's it, is it?
We could do better than that.
OK.
If I'm going to try and make a stronger acid than vinegar.
Right.
Because then we'll get more carbon dioxide, we'll get more pressure inside the fire extinguisher.
So, any thoughts about how to make a stronger acid?
The rocks that I can make acid from out in their hills over there.
Really?
Yeah. So I've got to go out collecting and crushing.
So Mike is off in search of rocks that'll make an acid stronger than vinegar, while I take Ellen and Hermione to an abandoned mine to find out just what's causing all that river pollution.
This mine hasn't been active for over 80 years. So what I don't understand is why it's still polluting the area.
Well, what we're seeing is actually the result of a natural process. It's not as though they themselves brought in any chemicals to the mine.
So this isn't a result of miners using, I don't know, cyanide or something to extract metals from
No,
rocks?
that's right. This is something that occurs naturally.
Yeah.
Essentially, what's happening is these rocks are rich in iron sulfide, that's pyrite. And when pyrite comes into contact with water and oxygen, it breaks down to release iron into the water and to form sulfuric acid.
Right.
And so this water that's coming out the mine, I suspect is acidic, but it also has a very high iron content, and you can see that because it precipitates out as this yellow coating on the rocks.
Right. OK. But if this was a natural process, surely the environment should be able to cope with that.
Well, that's because it's different from just it happening naturally. Humans have gotten involved, hacked in these huge holes, deep holes into the earth, and really exposed a lot of rock.
Right.
And they've also chipped away veins, allowing a lot more water to pour through, too. And so instead of having it on a small scale, it's now on a huge scale.
OK, so now that you have seen what you're up against, what's your next step?
We're going to collect some samples
And test the water.
OK, do you want to hand collect it?
Yes, please.
We're collecting water. Mike is out collecting rocks. He's on an old tailings pile. This is the stuff that gold miners have thrown away, but it's got just the rock that Mike is after.
It's called fool's gold. I don't know why I've been sent to look for it, but hey-ho. Ah, here we are. Look at this. Isn't this beautiful? This is fool's gold. Iron pyrite.
Now, where have I heard that before?
So let's start bashing away, harvesting the pyrite.
So the rock Mike is collecting is the same one that's polluting the mine water. And back at the mill, Ellen and Hermione are finding out just how toxic that water really is. Ellen has collected some microscopic animals from a local pond to see how they react to the mine water.
OK, so how are these tests going?
Well, this is the test for toxicity to aquatic life. And I've put some Daphnia in.
Yeah.
And they're dead.
What are Daphnia?
They're little water fleas.
Oh, those tiny little, very dead-looking things at the bottom of there.
But if you look in the clean water...
They're all hopping up and down.
Yes, they're jumping around. So we know that the mine water is toxic to aquatic organisms because Daphnia are pretty sensitive.
So we know that this water is toxic to water fleas. Do we know why?
Well, we suspect that it's acidic.
Right.
I haven't done the pH test yet.
OK.
So I'm going to do that now.
So good clean water would be what sort of pH, roughly?
A typical mountain stream should be around about 7. Now, if it's acidic, it's going to have a pH lower than that.
OK. So we're looking at kind of, if it were good, it would be yellow. So we're looking at to be orange or kind of pinky colour. Oh, that's very dark. I'd say that's almost 3 or 4 on there, would you?
Yeah.
No wonder the poor little things are all at the bottom with their legs in the air.
Yeah, and the other thing is when you have that kind of acidic water going through that kind of rock, there's got to be a lot of metals in there.
OK, so you've got acidity and a high level of metals. What on earth can you do to change that?
Well, I think I can have a go at the acidity using an alkaline rock, limestone, which is calcium carbonate.
Right.
And by passing the mine water through crushed limestone, I think that's going to help neutralise the acid.
OK, but what about all that metal? I mean, all that yellow that we saw over the rocks up at the mine?
Well, part of what can remove the metals is actually bacteria.
Really? But I thought bacteria would make it worse.
Yeah, a lot of times we think of bacteria as being negative.
Yeah,
but
absolutely.
in this case, they can really help us out.
Hermione goes off in search of rocks that will neutralise acid, while Mike and Jonathan are busy turning rocks into acid.
Before you do anything with that, Mike, what have you got in there?
This is iron pyrites, iron disulfide.
Is this what you chipped off the rocks you collected?
Ground it to a fine powder.
What sort of acid is it you need?
Sulfuric acid.
Sulfuric acid.
Yeah.
So this is your stronger version of the vinegar.
Yeah, this will produce much more carbon dioxide at a higher
Okay.
pressure. What we've got to do is heat this.
Right.
And have air passing over it. We produce a gas by heating the iron disulfide in air.
Right.
And the gas passes through water in these two containers. and it
Okay, so
dissolves in the water.
those two containers will end up being sulfuric acid.
Exactly, yeah.
That's all sounding quite familiar. So you're using air and water to break down the pyrite. Isn't that exactly what's happened to the mine water? Isn't that exactly what Hermione and Ellen are trying to reverse effectively?
Yeah, this is just a fast version of what's been going on in the mine, yeah.
So that's how you make acid. Meanwhile, Hermione's trying to reduce acidity. First, she has to crush the limestone she's collected. Then she adds a sample of the mine water. But what has Ellen got in that dustbin?
All I need is a little bacteria. And where's a great place to get it? Manure. Well, this is horse manure. It's nice, fresh, and juicy.
Now it's almost time to get the acid production underway.
I don't understand why you've got this big thing of water. How's that going to work?
Well, basically, this is full of water.
Yeah.
If I open the tap,
Yeah.
obviously gravity makes the water flow out.
Yeah.
So that produces basically a vacuum in here. So it sucks the air through the system.
Oh, OK.
So it's just the weight of the water moving down. So when I open this tap,
Yeah.
these should start bubbling because it's drawing air through the system. So if I turn it on,
Yeah.
that's...
Oh, yeah, it's bubbling almost instantly. Look at that.
Next, Mike needs to heat the pyrite. Jonathan's pump is sucking air through the system so that the pyrite is exposed to lots of oxygen. As the pyrite breaks down, it gives off acidic fumes. This gas bubbles through the jars of water where it dissolves, hopefully turning the water into sulfuric acid. As day one draws to a close, I leave Jonathan and Mike to their chemical labours.
Well, it's the end of day one of the water treatment challenge. And I'm really excited about this one because Ellen and I are tackling a real environmental problem.
But I'm very confident that we've got some acid, and it's just as well because without any acid, there'd be no fire extinguisher at the end of day 3. So fingers crossed again.
It's day 2 and the boys are up early.
So, you're going to do the acid test. So if this goes a sort of orangey or pinky colour, it's basically a success.
Yes.
OK.
See?
Oh, wow! That is unquestionably acid. That's pH 1, isn't it?
pH 1.
Fantastic. So is that just going to make you loads and loads of carbon dioxide? Brilliant. Brilliant. Well done, though. That's great. Look at that.
Success for Mike and Jonathan. But how's the mine water? Have the manure and limestone worked?
So do you want to test the mine water?
OK. We put them in at the same time. In it goes.
If this is 7, it should be yellowish.
And mine should still be that sort of dark orangey colour.
OK, ready?
Look, I can see the difference already.
Wow, look at that.
That's amazing.
Pretty good. So, well, mine's sort of six to 7.
Yeah, so it's pretty good. Basically, that indicates that the limestone is doing the right thing, is basically neutralising that acid.
Yes.
Well, you're going to have to presumably go and dig out a lot of rocks.
Yeah.
Okay. Call me when they're already up by the mine, will you? I'm not going to carry them up the slope. Now then, let's have a look. What do I say about this? Can I say that you have made it look considerably worse than it did yesterday?
And that's good.
Is it?
Yes, because
Okay.
we want the bacteria to be reactive.
OK,
Yeah.
but how on earth are you going to be able to tell that they've worked?
Well, I can't prove to you that they're taking the metals out of the water.
Yeah.
But another reaction that happens makes it smell really bad. And if you smell the right thing, then I know
Surely
they
this
are
is going to
working.
smell really bad anyway.
but yes, it smells a specific
it
way.
smells really of rotten eggs.
Yes.
Okay, so
when-
if you can smell that, you know that the right reaction is going on. So between the two of you, you will create a water that is a safe habitat for our water fleas.
Absolutely.
That's the plan. So all you've got to do is take these and scale them up big time.
Yeah.
Good luck.
I think we want a limestone layer at the bottom, but then I think everything else we want mixed.
It looks like cleaning up the water is a very messy job. The boys now have everything they need to make carbon dioxide gas, but Jonathan has an ingredient that he thinks will make the extinguisher more effective by making foam.
What are you doing?
This is a bit of Ellen magic, I hope. Ellen suggested I use the root of a licorice plant.
Really?
Which is what I'm doing here. Yeah, apparently in the third world, they use this for putting in foam fire extinguishers, and it just enhances the foam so that it lasts longer.
Just tell me about the role of this foam.
Yeah, well, the foam is obviously wet,
yeah,
so it's going to make the fire wet, but also contains lots of carbon dioxide, which covers the fire, restricts the oxygen, and so puts out the fire.
Because if you just squirted the gas, presumably that would just dissipate and not do anything.
Yeah. So what I'm going to do, I'm going to try it out.
Yeah.
So I've got the acid in there. If you could hold the funnel, I'll pour some of this in.
OK.
Let's just get it in there.
So this is just sort of ground up licorice root with a bit of water, is it?
Yep. I'm just adding some of the bicarbonate of soda to the acid.
Oh, wow!
Oh,
look at that!
And it's really different. It's sort of dense. You know, it looks much more like foam than just bubbles. It's really nice. Put a little bit more in.
Oh, it's going to come out the top. Absolutely fantastic. Because that acid was so strong,
yep,
does it not mean that this foam is going to be quite acidic? And surely we don't want to be spraying that around.
Yeah, no, I was worried about that as well. So we've got some of this paper, indicator paper.
Okay.
So let's try it out on the foam.
This is fantastic.
Well, look at that.
Oh, it's yellow.
That's
and that's pH, what do you think, 6 or
7?
6 or 7. So it's neutral.
Yeah, so although, I mean, you still don't want...
So Jonathan has all the ingredients, but he's still got to work out how to keep them separate until the extinguisher is needed. With just 24 hours to go, it's time to install the treatment plant. But that means getting it up there first. Thank goodness I didn't get roped into this. Everything's in place, now the real work can begin. First, the pipe to feed the mine water into the bottom of the bin. This bin contains the manure, packed with bacteria that are going to clear out the toxic metal. Rather than drag the bins right up to the mine, they're going to pipe the polluted water down.
OK, ready, Ellen?
But that's easier said than done.
How much more? Hang on! Ellen, stop! See if you get water! I've got the water in it!
So let's hope those dustbins do their job. Mike and Jonathan are working hard on the extinguisher. The acid production is coming on well, but Jonathan is still trying to figure out how to make the foam on demand.
I've decided to use this for the fire extinguisher. I'm going to probably fill it maybe a third of the way up with Mike's acid, something like that. But the thing is how to keep the bicarbonate of soda in there so it's not mixed with the acid until you want to use the fire extinguisher. So I've been playing around with some of the rubber sheeting, just cutting them up into discs, and perhaps I can make a little holder with the rubber. Then I can fill it up with the bicarbonate and assemble the thing.
So Jonathan still has to turn a bottle and some rubber into a working fire extinguisher. Ellen and Hermione, however, seem well on the way to success.
Wow, is this it? Yeah. The water purification plant. Not looking terribly pure at the moment, though, is it?
No, but it will at the end.
OK, so just explain what's going on in this bucket.
Well, it actually starts up in the mine.
Yeah.
And we have a tube that comes right from the mine, and it carries the toxic acid and metal water right into here. But we have it going straight down to the bottom of the bucket.
Yeah.
And then filtering up through all the manure.
So is this where the manure is really doing its job?
That's what it should happen, yeah.
Okay.
But there's a little bit of a problem. It takes a while to start because there's two kinds of bacteria. One that loves oxygen.
Yeah.
And one that doesn't.
Okay.
Now, we want the one that doesn't. However, they don't start to work until all the oxygen is gone.
Right.
Thank goodness, the bacteria that like oxygen will start, and they should be working immediately.
So the bacteria that you need will kick in as soon as the oxygen-loving bacteria has basically used up the oxygen in the system.
Yes.
The water coming through here
would still be acid, but wouldn't have many metals in it.
Okay. And so what's going on in this one, Hermione?
Well, this is basically just a settling pond.
Right.
In a dustbin. You can see the water that comes out is pretty mucky.
Yeah.
So this will just give a chance for all that organic material also to settle out.
Right.
Before it flows into our limestone traps. We put the pipe at the bottom so it's going to filter up through the limestone bed, reduce in acidity, come out this pipe and go into a second one for good measure, filter up, and by the time it comes out here, it should be neutral.
Okay, so basically, if all the systems work, if the bacteria do their thing and the limestone does its job, the water that comes out of here should be water that any water flea would be happy to live in.
I hope so.
Confidence, Hermione, confidence!
Okay, yes, Kate.
Okay.
Yes.
Don't really know what I'm going to do exactly tomorrow, and I'm sort of lacking a little bit of inspiration.
Well, Ellen and I have got everything in place for the water treatment plant by the end of day 2. But it's just totally unknown whether or not it will all have time to settle and have time to work.
It's day 3, and Hermione and Ellen are keen to see how the water treatment plant is getting on.
This looks really good.
That looks brilliant, doesn't it? Really settling.
Yeah.
But have the bacteria started working? There's one way to find out.
What do you think? Let me smell.
Ha! I knew you'd want to. What do you think?
It's quite stinky.
Yeah. We've got the bacteria we want working, but they're not at full force yet.
With only hours to go, those bacteria had better get a move on. It's time to put the fire extinguisher together. The acid licorice mixture goes in the bottom of the bottle.
This is going to hold the bicarb. So I'm hoping there's going to be enough.
And the bicarbonate in the rubber cradle. That way, the two are kept separate until the extinguisher is activated by turning it upside down. That's the theory, but will it work in practice?
OK, shall we go and try it outside?
I'm first in line.
OK. So we just need to turn it upside down, and it should start the reaction, shouldn't it?
Oui.
OK?
All right.
Whoa!
So they're generating plenty of carbon dioxide, too much, in fact, for the extinguisher to cope with.
Whoa!
They need to find a way to secure the top, and there's not long to go. Time is running out too for Ellen's bacteria. How's it going up here? You had a pretty cold, wet start to the day, didn't you?
It started,
yeah.
So we've got some action going. Hopefully it'll be enough.
Okay, good. So that's actually looking a lot clearer than yesterday.
Yeah. It's flowing very slowly, very smoothly. Looking great.
Perfect, okay. And this watering can? What's this for?
Instead of just having it coming out a tube, we wanted it to come out the rows here so the water gets aerated before it joins back in the stream.
Perfect. Well, let's hope that what you're putting back in this stream is good.
Yes.
And the only way we're going to do that
Test it.
is to test it. Have you got a bottle to fill?
Yes.
Because back at the mill, there are some little water fleas who are currently quite nervous.
Only if the water has been successfully cleaned up will the water fleas survive. Meanwhile, the boys are in a race against time. Will their extinguisher be ready to face the fire?
We need a fire again! Fire! Come on, there's a fire! Look at you two. You know you're more likely at a beer festival. So these really are the fire extinguishers that are going to put out that fire.
Mobile foam.
OK, do your worst.
OK,
Are you ready?
All right. Whoa!
I don't believe it! Wow!
Sorry, mate.
That is amazing!
It's all out, love. It's all out, love.
You guys are heroes! Well, disaster has been averted, but are those water fleas still alive?
I bet they are.
Let's go find out. Okay. Put the bell down. Now, talk us through.
Okay. Well, this is our treated mine water.
Yeah.
That's the nasty mine water.
So that hasn't gone through the water purification plant?
No, that's straight out the mine. So you can see there's a good difference in colour.
Okay, but is colour important?
Well, it's an indication, I hope, but pH is the real test for the acidity.
Okay.
So hopefully this will be up
Could you pick her up?
6 or 7.
Oh my word, look at that.
Oh, yes. Oh, yeah, well, we're 6.
6, maybe inching into 7. Gone up from 2 or 3, was it before?
3 to 4-ish.
Yeah.
We've gone up 6 to 7. That's not bad.
Okay, so acidity, the limestone worked, but
They're kicking.
they are
kicking.
Look at them! How long have they been in here?
Over an hour.
And they're still buzzing around. In fact, hang on. They're cheering. That is magnificent. Well, all of you, congratulations. A victory well won, I think. Well, the team fought a battle against fire and pollution and emerged victorious, but next time they face an even more massive task. Any idea how to weigh a mountain? Find out on the next Rough Science.
For a free survival science pack and details of all Open University programmes, call 0870 900 9581 or go to open2.net, where you'll also find more video diaries from the Rough Scientists.